Yeah, welcome back. Let's solve remaining questions very quickly. I think the last one we did was number 13. Yes, number 13. So the next one is number 14. Let's go straight to it. Number 14. An aircraft flies around a triangular course. An aircraft flies around a triangular course. The first leg is 200 kilometers on a bearing of 115 degrees, and the second leg is 150 kilometers on a bearing of 230 degrees. How long is the third leg of the course, and on what bearing must the aircraft fly? Okay, let's go. Let's take that. First leg is 200 kilometers on a bearing of 115 degrees. So let this be where it is starting from. Bearing of 115 degrees, that's going to be somewhere around there, and the distance is 200 kilometers. Let's put that here. So this bearing is 115 degrees. Now this is where it is now. This is the first leg. Just trying to make the diagram as clear as possible. Yeah, first leg is from this place to this place. Now the distance is, the bearing is 115 degrees, and the distance is 200 kilometers. And the second leg is 150 kilometers on a bearing of 230 degrees. So it's now flying another 150 kilometers on a bearing of 230 degrees. That's going to be somewhere around there. We know that the whole of this is 270. So 230 will just be somewhere around here between this place and this place. So let's make it 90, 180, 230 will be somewhere around there. And the distance is 150 kilometers. Yeah. This is 230 degrees. So distance is 150 kilometers. This is where it is now. And the distance is 150 kilometers. 150 kilometers. The length of the second leg is 150 kilometers. Now the question is, how long is the third leg of the course, and on what bearing must the aircraft fly? The third leg is going to be movement from this place to this place. That's how it's going to form a triangle. So that means, what is this length? And on what bearing must it fly to get to this point from here? So the question is, we want to find this length, I want to find this bearing. Yeah. The bearing on which it must fly is the bearing of this point from this point. So that's this angle, the angle that runs from the north to the line that joins this point to this point. I'm just sketching what we want to do first before we start, so that we can just do it without any difficulty. All right, so let's go. That's what we need to find now. So now let me name the points. Let me call the first point here A, the second point B, and this place C. So first leg is AB, second leg is BC, and the third leg is CA in that triangular form. Now, so if this is 115 degrees, that simply means this small one is 90 minus 115 degrees, which is 25 degrees. So that means this small angle is 25 degrees. If that's 25 degrees, this will also be 25 degrees, alternate angles. 25 degrees. Now, if the whole of this is 230 degrees, it simply means this one is 40 degrees, which is 270 minus 230. Yeah. So the whole of this therefore is 65 degrees. Now how do I find the length of the third leg? That's side B of triangle ABC. So using cosine rule, B squared is equal to 200 squared plus 150 squared minus, I need to write that, B squared equals 200 squared plus 150 squared minus 2 times 200 times 150 times cos 65 degrees, and that's equal to, let's do that here, 200 squared plus 150 squared, 200 squared plus 150 squared minus 2 times 200 times 150 times cos 65, and that's 37,142.9. So that means B is equal to the square root of that, 37,142.9, which is, what's the square root of our answer? That's 192.73. And they said we should give answers correct to 3 significant figures, and that's simply 193 kilometers. So the length of the third leg is 193 kilometers. Now its bearing, the bearing of the third leg is this. This is the bearing of the third leg. The angle from the north pole here to the line that joins this point to where it started from. I can make that finer. That's the bearing of the third leg. That's the bearing of the third leg. So that means I only need to find, what can I do here? What can I do here? This looks a bit tricky, but I think it's simple still. I think it's simple still. I need to know this angle. Okay, first of all, if this is 40, this is also 40 degrees. Alternate angles. Yeah, that's correct. So if this is 40, that simply means this is 50 degrees. Maybe I should select another color for that. That simply means this green angle is 50 degrees, 90 minus 40. So if I know the whole of this angle, if I know the whole of this angle, I'll just subtract 50 from it to get this tiny one. Let me call this tiny one. Let me call this tiny angle, this very small angle. Maybe I need another color for that. Let me call this very small angle. Let me call this angle alpha. So if I call this theta, theta minus 50 will give me alpha. And I know that 360 minus alpha will give me the bearing on which the aircraft must fly to do the bearing on which the aircraft must fly to go on the third leg. Yes, to travel on the third leg. So that's 360, which is the whole of this, minus, that's 360 degrees. So the bearing of the bearing on which the aircraft must fly is going to be 360 minus alpha. Yes, 360 minus alpha. That's what will give me the bearing on which the aircraft must fly to go the third leg or travel the third leg. So that it is always best to analyze what you are supposed to do or what you want to do before you go ahead and to do it. Otherwise, you get to a point and see that approach was an extremely wrong one, and you begin to, you have to go over it again, and that can be really frustrating. So now that's what I need. I need to find theta in triangle ABC. So let's go. I know that 200 over sine theta will be equal to b over sine 65 degrees. Yeah, that's it. So that's what I'm writing. Let me paste a tiny image of a diagram. Yeah, this is just the second part of the question. They didn't call it b. So I'm doing 200 over sine theta equals b over sine 65 degrees. And that simply means 200 over sine theta equals b is 193, approximately 193 over sine 65 degrees. When I cross multiply and make sine theta the subject, sine theta will be equal to 200 sine 65 degrees over 193. 200 sine 65 degrees sine 65 degrees divided by 193, and that's equal to 0.9392. So theta is therefore the sine inverse of 0.9392. Sine inverse of that answer is what? That's 69.914 degrees. Now that simply means the bearing on which the aircraft must fly to travel the third leg, or to complete to travel the third leg and complete the legs, is going to be 360 minus alpha, which is equal to 360 minus 69.914 minus 69.914, which is 290. I hope I'm doing the right thing. Let me check that first of all. 360 minus, yeah, that's it. Oh, I need to get alpha first. Alpha is theta minus 50. Look at that, I almost goofed. I need to get alpha. Math can be very funny. That's why you have to check again. Let me paste the diagram. I'm pasting a bold diagram now. Now, if I already know theta. Theta is 69.914. So alpha is going to be theta equals 69.914 degrees. So that means alpha equals theta minus 50, which is 69.914 minus 50, and that's equal to 69.914 minus 60. That's going to be some 69.914. That's going to be a decimal fraction setting minus 50, and of course that's 19.9. It's always good to be sure of what you are doing and don't be too confident. That's 19.914 degrees. It's funny at times how you even think you are not sure what 2 plus 2 is going to give. 19.914. Now we can find the bearing on which the third leg the aircraft must fly to travel the third leg, which is this angle simply, which is this angle from this place to this place, and that's 360 minus alpha. Yeah, that's 360 minus alpha. So therefore the bearing on which the aircraft must fly for the third leg, or to travel the third leg, is equal to 360 minus alpha, and that's 360 minus 19.914. Let's do that. 360 minus 19.914, and that's 340.08 340.086 degrees. I did some approximations, so it's possible. Yeah, that's okay. Let me just do a quick check. 69.914 minus 50, that's 19.914, and now 360 minus 19.914, and that's 340.086 degrees. So that's it, very, very, very simply. All right, let me do the last one very quickly. I was almost going to say we should come back to that, but let's do it once and for all. The last one, which is number 15, is villages A, B, C, and D are such that B is 4 kilometers due east of A, C is 3 kilometers due south of B, and D is 4 kilometers south, 50 degrees west from C. Calculate the distance and bearing of A from D. That's a funny one. Villages A, B, C, and D are such that B is 4 kilometers due east of A. So if this is A, if this is village A, village B will be 4 kilometers directly east of A. Let me say this is where B is, village B, and the distance from A to B is 4 kilometers. C is 3 kilometers due south of B. C is 3 kilometers due south. That means directly south of B, 3 kilometers. Let me make this B. I'm trying to make sure that 3 kilometers is no longer than 4 or of the same length as 4 kilometers. That can make your work a bit confusing. Yeah, C is 3 kilometers due south of B, and D is 4 kilometers south, 50 degrees west from C. They said southwest, so it should be southwest. You take the bearing this way and not from the north, in this direction. That's southwest. So D is south. D is 4 kilometers south, 4 kilometers south, 50 degrees west from C. So 50 degrees west is going to be somewhere around there. That's southwest, and it is 4 kilometers, just as long as AB. Yeah, that's 50 degrees. That's south, 50 degrees west, and the distance is 4 kilometers. Let me put village D here. Let this be village D. Shorten this a little. That's village D. Now, what's the question? Calculate the distance and bearing of A from D. First of all, distance. Let's find distance. Distance is the line that joins A to D. Maybe I should put A here so that it will be easy for me to join A to D. Yeah, this is A. Now this is AD. That's AD. Yeah, that's it. I can even adjust the entire diagram by moving it a little sideways here. So that's AD. They said distance, calculate the distance and bearing of A from D. So I'm finding distance DA and the bearing of A from D, which is this angle. That's the bearing of A from D. So let's go to that. I can put my measurement length outside now. Yeah, so let's say that. How do I find distance DA first of all? This, I can even remove this now. How do I find distance DA? Okay, first of all, I can do this. I can do this. If I join this, if I join A to C, I will have another triangle. Yeah, I think that's going to be reasonable. I can use Pythagoras' rule to find AC. Let me call it let me just say AC squared. Of course, this is a right angle triangle because this is due east and this is due east and this is due south. So I can say AC squared in triangle ABC. AC squared equals AB squared plus BC squared, which is 4 squared plus 3 squared. And that's 16 plus 9, 25. So length AC is therefore the square root of 25, which is 5 centimeters. 5 kilometers. That's 5 kilometers. Now, how do I find distance DA? If this is 50 degrees, then this is going to be 40 degrees. 90 minus 50. So, now that we know that, how do I find this one? Okay, I already know now that this is 5 kilometers. So, what else? How do I find this small angle? Oh, I can use... what do I need to find this small angle? And this looks tricky, but I think it's simple. I think it should be simple. Let's see. If I know this angle, is it going to help in any way? Okay. That's simple. I just got it. I want to find this purple angle. Let me call it alpha. And to find that, I can find this one first. I can find this blue one first. Let's call that theta. Yes. So sine theta is opposite of hypotenuse. In right angle triangle ABC, sine theta is opposite of hypotenuse, which is 4/5. Sine theta. I'm bringing the diagram down. I'm pasting a small image. Okay. Let me even paste the whole of it here. Yeah. Sine theta equals opposite, which is 4 over hypotenuse, which is 5. And that's 4 divided by 5 is this 0.8. And that simply means, push that. I think I should just delete the whole of it. I've used it for what I wanted to use it for. Now, that simply means theta is equal to the sine inverse of 0.8. At times, it takes a while to figure out what to do. But if you are patient enough, you'll be able to figure it out. Just take your time and you'll get it. Sine inverse of 0.8. That's 53.13 degrees. So now, how do I find... I wanted to paste a bigger image. Now that I know theta, how do I find alpha? Alpha is certainly 90 minus theta. So alpha equals 90 minus theta, which is 90 minus 53.13. 90 minus 53.13, and that's 36.87 degrees. So now that I know alpha, it simply means the whole of this angle, let's try to change colors. The whole of this angle is 40 plus alpha, which is 36.87 plus 40, and that's going to be 36.87 plus 40, that's 76.87 degrees. That's 76.87 degrees. Now I can use that to find length DA. So therefore, DA, let me call it, DA is the side facing angle C in triangle ADC. So I can call it C simply. So C over sine T is equal to, I hope I'm doing it. No, I'm not using sine, I'm using cosine rule and not sine rule. So C squared equals 5 squared plus 4 squared in triangle ADC. 5 squared plus 4 squared minus 2 times 5 times 4 times cos 76.87 degrees. Cos 76.87 degrees, and that's equal to 5 squared plus 4 squared minus 2 times 5 times 4 times cos 76.87. I hope I added correctly when I did 40 plus alpha. Yeah, 76.8 cos 76.87, and that's 31.9136. So C is therefore the square root of that, 31.9136, which is, what's the square root of that answer? And that's 5.649, which is approximately 5.65 kilometers to 3 significant figures. Now that answers the first part of the question. Now the second one says that's the distance of A from D. I can even call it, therefore distance AD equals 5.65 kilometers. Now distance and bearing of A from D. Now how do I find the bearing of A from D? That's also, if I'm able to find this small angle. If I'm able to find this small angle. Yeah, no. Yeah, first of all, I'm going to find the whole of this angle. Let me call that beta. And then find this small angle. Where are my colors? And then find this small angle. This small angle, I want to call that, I've used alpha, what can I call that? I want to call that angle W. Let me just label it. No, is that even going to work? Yes, that's going to work. Let me call this alpha, beta, gamma. Let me just call it W. Let me call this small angle W. Let me call that tiny angle W. Yeah. So if this is, before I find that, if this is, maybe I can label this, the angle outside. I'm calling this small angle W. Okay, it's better there too. I'm calling that small angle W. So that means if this is 40 degrees, this is also 40 degrees. No, I don't need that. If this is 50 degrees, this is also 50 degrees. Yes. So that simply means angle W is going to be beta minus 50 degrees. And the bearing I want is going to be 360 minus W. So let's go to that. I'm now going to say 5 over sine beta is equal to C over sine 76.87 degrees in triangle ADC. Let me copy the diagram and paste a tiny image of it. Let's paste this small image. Now, 5 over sine beta is equal to c over sine 76.87 degrees. And that simply means 5 over sine beta equals, what did I get as C? That's 5.65. 5.65 over sine 76.87 degrees. Now, if I cross multiply and make sine beta the subject of the formula, we'll get sine beta equals 5 times sine 76.87 degrees over 5.65, and that's equal to 5 sine 76.87 divided by 5.65, and that's 0.8618. So beta is therefore the sine inverse of 0.8618, and that's 59.522. So that's beta. That means W, therefore angle W, which is beta minus, which is beta minus 50. Of course, W is beta minus 50. Yeah, W is going to be beta minus 50. That's it. Because W plus 50 is beta. So beta minus 50, and that's equal to 59.522 minus 50 minus 50, and that's simply 9.522. So therefore the bearing of A from D is now going to be 360 degrees. We know that from this place to this place is 360. So the bearing of A from D, which is just this, will be 360 minus the tiny W. So therefore the bearing of A from D is equal to 360 minus W, which is equal to 360 minus 9.522. 360 minus 9.522, and that's 350.478. And angles are supposed to be given correct to 0.1 degree. That's 350.5 degrees. And that's it, very, very simply. You can also write this as north. This is also the same as north 9.5 degrees west. It's the same as north 9.5 degrees west. So that's it, very, very simply. This was kind of long, but hey, it's a good thing you understood it. Thank you very much. Thank you very much. I'll catch you in the next. Bye bye.